are continuing to solve equations, but these are going to have a couple extra pieces involved with them. So on the last section, all of our angles were always a theta. These we might see a 2 theta or a 3 theta. If you think back to graphing, if I said like sine of 2 theta, what did that 2 do to our graph back in chapter 4? A number out in front changed the amplitude, a number with the angle changed our it made it narrow. Yeah. It changed the period of the graph, how long it took to repeat. Normally, sine, cosine, everything except tangent and cotangent have a period of 2 pi, or 360. If I put a 2 in front of that, my graph gets skinnier, and now its period is just pi, or 180 degrees. So if I were wanting, like every time sine 2 theta equals 1/2, for instance, and I said everything between 0 and 2 pi. Well, normally, between 0 and 2 pi, your graph would look like this, and we would get 2 solutions, one here and one here. But because that 2 would shrink our graph in, how many solutions are we actually going to get here? 4. Because our graph got narrower, we got more solutions in there. If it had been a 3 theta, then my graph would have repeated itself 3 times, and I would have gotten 6 solutions. So that's what we're looking at today. The only difference is that number with our angle will change how many solutions we get. A good way to think about it is if it's a 2, we're going to get double the solutions. If it's a 3, we get 3 times the solutions. If it's a 4, we will get 4 times the solutions, because it changes how many times it repeats. Okay, let's take a look at this example. We are going to solve this 2 different ways. First one just between 0 and 2 pi, second one for all possible answers. We're start solving it just like you were solving before. So what would your first step be? Radical 2. We'll try and get the cosine by itself. And then we would divide by 2. Okay. You cannot get rid of this angle right here. I can't just say I'm going to take everything times 2 and cancel it, because it's inside the cosine. So right now we're going to stop and we're going to evaluate. Cosine is equal to a positive. When is cosine positive? Reference angle, we are in radians. When is cosine radical 2 over 2? 45 degrees, which is pi over 4 in radians. Okay, so what that means, normally you would just write x equals and you were done here. My angle is x over 2, so it's going to be x over 2 equals pi over 4 in quadrant 1 is pi over 4. Pi over 4 in quadrant 4, 7 pi over 4, double minus 1. Okay, now if I'm trying to solve for x, what do we have to do? Multiply everything by 2. So x equals pi over 4 times 2, which would be pi over 2, and 7 pi over 2. Okay, so for part A, I wanted every answer between 0 and 2 pi. because this wasn't like a 2x, I don't necessarily know that I got double the solutions. What does that x over 2 do to your graph? Stretches it out. Let's check and make sure both of these do fall between 0 and 2 pi. Pi over 2, we know that's on our regular unit circle. 7 over 2 is like 3.5 pi. Is that between 0 and 2 pi? No, that one's too big. It's outside our answer. So part A, the only answer between 0 and 2 pi is pi over 2. So we just have to check that. Part B, I want all possible solutions. So previously, we would just take each of our answers and add 2 pi k or 360 degrees k, because that was the period. If I wanted the period on this, we always did, remember, our normal period, which was 2 pi, divided by the coefficient on x. That's 1/2. So that would be a 4 pi. So for all possible solutions, all I have to do is take each of my answers and add my period, which was 4 pi. And I put a k with it because you can add it as many times as you want, where k is an integer. You can write that out in words or symbols. So that's the new piece. We have to check and make sure we get all of the answers in our interval and throw out any that don't fall in the interval. And if I say all possible answers, you have to go back and find your period like we did in chapter 4. For, sine, cosine, secant, cosecant, that's just 2 pi over k. Remember, tangent and cotangent were the weird ones. We did pi over k for those. What questions do you guys have right there? Did it confuse you? Good. Let's just keep working some. Based off what we talked about previously, how many answers, or what's this 3 going to do to our answers? Yeah, we're going to get triple the solutions here, because what this means is between 0 and 2 pi, sine will actually repeat itself 3 times. Okay, so I like to make a note of that. That just helps me when I get to the end to make sure I have all of my answers. So if I want to go solve this, our first step is always to get our trig function by itself. But if you look at this, it is. So now we just ask ourselves, we're in radians, when is sine equal to -1? Sine of 0 is 0. 270 degrees, which in radians is 3 pi over 2. If you're looking at your unit circle, sine is your y. You're asking yourself when y is -1. 3 pi over 2. So what that means is my angle is equal to 3 pi over 2. So to solve for x, what would we do? Divide by 3. So 3 over 2 divided by 3 would be 1/2. So pi over 2. Now we need to answer our questions. Part A. On the interval 0 to 2 pi. Pi over 2 definitely falls in that interval. But remember what we talked about. Because this is a 3x, my graph of sine is actually going to repeat itself 3 times between 0 and 2 pi. So it's actually hitting that value 3 times. How do I find the other 2 answers? You could graph it, or we could just know that from here to here, this is the period of the graph, right? Period is how long it takes to repeat. So the period of this, normal period for sine is 2 pi divided by the number in front of x, so that's 2 pi over 3. So to get my other 2 answers, all we have to do is add 2 pi over 3. So if you do that, you could, if you need to use your calculator, do 1/2 plus 2/3. What do you get? 7 pi over 6, and we need 1 more. So take 7 pi over 6 plus 2 pi over 3, 11 pi over 6. If you added it one more time, go ahead and add 2 pi over 3 one more time. 5 pi over 2, that's like 2.5 pi. That's outside my 0 to 2 pi window. So you just, basically, we knew we were going to get triple answers. So since I had 1, that meant I would have 3 total. Or you could just think I'm going to add my period until it's bigger than 2 pi, and then I stop. Okay, B, for all solutions, all we have to do is take our original solution, which we only had 1, it was pi over 2, plus what? Your period times k, where k is just an integer. So basically every time you add or subtract 2 pi over 3, you've gotten all the way around the circle, you are back to where you started. Because if you add 2 pi over 3, it gives you this. So it would just be repetitive. Wouldn't really be wrong, just not needed. Yeah, Lena?
So how do we get the period?
For sine, cosine, secant, and cosecant, period is 2 pi divided by the number in front of x. Tangent and cotangent are different because their normal period is just pi. So for those, it's pi divided by the number in front of x. Or if we were in terms of degrees, we would do 360 over that. Other questions? Let's just try a few more today. What would you do first here? Or what do you notice about this? There's 2 trig functions, and if you look, their angles aren't the same. I would like to have the same angle before I go to solve this. So I noticed a couple of you grabbing your flip charts. Cosine 2x, that was under our double angles. Right, we have 3 different options for cosine 2x, don't we? because my other function is sine. So that is 1 minus 2 sine squared x. Now what do we do? Okay. I'm going to put them in decreasing order. This is a box method, but I prefer to have a positive sign squared if I'm going to do box method, so I'm going to multiply by negative 1. Alright. At this point, let me ask you a question. Is this any different than the problems we were doing yesterday? No, because the original problem had a 2x in it, but we used an identity and got rid of it, so am I going to have to worry about double or triple solutions or solutions that don't fall in my interval? No, this is just like our old problems. So we just need to box method. So those multiply to a negative 2, and they need to add to a positive 1. How did I get what? You have to multiply these two together, so 2 times negative 1 gives me negative 2. Okay, so now if we set each of those to 0, we get sine to be a 1/2 and a negative 1. Alright, let's solve each of these. When is sine a positive? We are in radians. When is sine 1/2? Pi over 6. So pi over 6 in quadrant 1 is pi over 6. Pi over 6 in quadrant 2, remember in quadrant 2 the numerator is 1 less. And then sine x equals negative 1. When is the one time on the unit circle when y is negative 1? I only asked for the answers between 0 and 2 pi. So I don't have to do the plus 2 pi k or anything. My angle was just an x, so I don't have any other steps from here. We are done. Questions here? Let's try a couple more. So this problem, we could use a formula, but would we have to? No, because I only have one trig function. So we could just get this cosine by itself. How do I do that? Divide our square root of 2. So it's cosine 2 theta equals 1 over radical 2. If you multiply, that would be radical 2 over 2. Okay, this is a 2 theta. What does that tell me? Double solutions. What is the period here? 2 pi over 2, which is just pi. Okay. When is cosine negative?
Second.
2 and 3. Reference angle. When is cosine radical 2 over 2? Pi over 4. So, since this was a 2 theta, down here I have 2 theta equals pi over 4 in quadrant 2 is 3 pi over 4. Pi over 4 in quadrant 3. In quadrant 3, the numerator's 1 higher, so 5 pi over 4. Now what do we do? Divide our 2. It's like multiplying by a half, so we get 3 pi over 8 and 5 pi over 8. Am I done? No. I got 2 answers here, so how many total answers should we have? 4. What we need to do is add our periods to each of these original answers. So if 3 pi over 8 is an answer, add pi to that, and you get okay, to get the second answer, we have to add our period to my 5 pi over 8. So 5 pi over 8 plus pi. If you tried again, if you added pi to each of those one more time, it would be bigger than 2 pi. So we know we've done too much. Is anybody confused about the period stuff? There are other ways I can teach it, but I don't want to give you too many options. If the first one makes sense, I just want to stick with that so I'm not confusing you. If anybody is getting confused on that, let me know. I can show you other ways to get the rest of your answers. You just have to find the way that makes the most sense to you. Want to do one last problem for today? Then we'll finish up tomorrow. What do you notice here? Okay, we're in degrees this time. We can't do box because I have 2 different trig functions. Is there a way to avoid the 2 different trig functions? What do you want to replace? So let's replace, it doesn't really matter, let's replace sine squared of x. Okay. So I'm replacing sine squared with 1 minus cosine squared x. It's kind of the trick you had to use during your last problem on the homework. So if we distribute, add our like terms, then what do we do? Do I have to worry about double solutions or answers that don't work on this? No, because my angle is an x. That's only if it's like x over 2 or 2x or 3x, something other than x. So this is just like normal problems. Divide by 4. To get rid of a square, we square root. With that, you do plus and minus. So cosine equals plus or minus square root of 1 is 1, square root of 4 is 2. Since it is positive or negative, how many answers am I going to have? 4. We're going to do every quadrant. Reference angle in degrees. When is cosine 1/2?
60 degrees.
So my angle is x. So 60 degrees in quadrant 1 is 60. Quadrant 2, 180 minus 60 is 120. Quadrant 3, 180 plus 60, 240. Quadrant 4, 360 minus 60 is 300. That's for part A. Part B wants all possible solutions. So what would I have to do?
Plus 360 each one. Plus 365.
Right. We're in degrees. My period was 360, so you could add 360 k each. There are some other ways you could write it on this one, but this one is perfect and probably just the easiest to go with. Where k is an integer.
Do we have to write the k as an integer?
You should. We are stopping here today, and tomorrow we will do 3 or 4 more examples, and then have some work time. Today I'm going to give you a couple homework problems that I would like for you to go ahead and start. So 4 problems for you to do tonight.